Okay, so R Markdown. R Markdown is like huge and super vague, as what I'd actually like to talk about. So I was thinking I need a tagline. So maybe tagline like R Markdown is our secret ingredient. It's our special sauce. It's R Markdown an incomplete history, or R Markdown stuff I'm working on and want to show off. The last one is Garrick does that thing again where he makes too many slides and then tries to talk through them all. So, all right, let's see. Um, so first, a little bit about me. Hi, I'm Garrick Aden-Buie. I tweet at GRRRCK, Gurk, online, and that's probably the easiest way to get a hold of me. And I also have a website, garrickadenbuie.com. Recently joined RStudio and generally work with Grade This and Learn R. And these are two pretty cool packages that heavily rely on R Markdown and kind of some neat things behind the scenes. And that sort of it prompted me to like think about this and to kind of talk about what I want to talk about today. So let's just get ourselves in the mood for thinking about R Markdown. And I'd like to ask you to give me some ideas about what R Markdown is. But in typical internet style, let's do wrong answers only. And feel free to go ahead and drop your what is R Markdown, what isn't R Markdown in the chat, and I'll add them to the slide. So maybe you have some feelings about R Markdown, maybe you like know what it is and have kind of heard of it. Maybe you've never heard of it and just want to make something up. Go ahead and find the chat window. And oh, there we go. So Thomas says, R Markdown is this. Or maybe R Markdown writes your papers for you. Evil tool, not LaTeX. Tropical bird. Echo equals false. Bane of my existence. Oh, knitting. Knitting, but doesn't make you warm. I love this. Yes. Or maybe, do I really need another Markdown? I love that one. So, okay, great. These are all awesome. Some of these are actually right. Some of these are totally wrong, but some of these are actually right, which is kind of neat. And you probably have like, and this kind of touches on some of these things. Like, what are all these options? What are these like backtick things, and what's the deal with that? R Markdown is definitely not LaTeX, and that's probably a good thing that it isn't. Echo equals false. What's the deal with knitting? Why do we call it knitting? Where did that come from? What's that idea? So thank you everybody for sharing. And all right. So to kind of motivate for me what R Markdown means, I have this sentence. We're going to come back to the sentence a little bit later on, but as data scientists, it's pretty common that you'll end up writing a report that involves some kind of data. So here, this sentence comes from an actual report, but it's also kind of related to data that was made available through Tidy Tuesday. We'll come back to this in a second, but let's just think about these numbers here. So break free from plastic engaged 14,734 volunteers in 55 countries to conduct 575 brand audits. These volunteers collected 346,494 pieces of plastic waste. So these numbers are special. Each of these numbers is related to a piece of data somewhere. They're special in the sense, like at a very minimum, as data scientists, we have to like figure out how to calculate these numbers and get them into this sentence, right? So we have to like solve that problem. But beyond that, they're also very meaningful. Like they come from something, they have meaning. We're distilling a lot of information into this. And so these numbers are important, and we want to be able to write this sentence in a way where we treat these numbers as special and important, and not just copy and paste them out of Excel and drop them into this sentence where they're sort of thrown off and could be sort of not changed easily or not updated when our data updates. So we're going to come back to this sentence in a little bit, but I thought it would be nice maybe to talk about a brief history of R Markdown. So where does R Markdown come from? And I feel a lot like this guy. This isn't me, but like it almost could be. Like this is like the phone that we had in the 90s in the kitchen that you had to make a phone call on. And like I'm trying to like talk to some people who you know, their idea of a phone in the kitchen is like it's on a stand and it's giving you a recipe. So I'm going to just like totally date myself and talk a little bit about R Markdown in the past and where it came from, because I think it's actually really interesting. So to do that, we're going to start with first a brief history of literate programming. And you might have heard R Markdown called literate programming. We're going to leave R Markdown behind for a second. We're going to talk about this guy, Donald Knuth. So he has this paper called Literate Programming, and in it, he says, hey, let's change our traditional attitude towards how we write programs. So instead of imagining that our main task is to instruct a computer what to do, let's instead concentrate on explaining to human beings what we want the computer to do. And so like he's really kind of touching on this idea that the code exists, the code that we write exists on the one hand to like get something done and make the computer do it for us. And on the other hand, it's an artifact that we use to explain to other people what we did when we did it. Cool. So here's some other really kind of funny quotes in this paper. It's a really interesting paper, and I highly recommend you read it if you're like, if you are somewhat into R Markdown. So I was coerced like everyone else into adopting this idea of structured programming. He's like, but because like you don't want to ever be called like, you don't want anyone to say that, you know, you're writing unstructured programs. So he's like, now this is my chance to get even. I'm going to call it literate programming so that everyone wants to do it and nobody wants to be called or admit that they're writing illiterate programs. So the whole paper is full of these like kind of jokes. Some of them are funny on purpose and some of them are kind of funny like in retrospect. Like he named his system Web, and because nothing else had been called Web yet, and little do you know, later on there'd be this whole thing called the Web, and that kind of ruined his name for him. But the idea of literate programming stuck around for a while. So like, what did this look like? So the idea that he kind of put forth in the paper was, okay, you're going to write your code and the stuff that is important for humans to understand what the code does, you're going to put that all in the same place. You're going to put it in one document. And that document is called like a web. And to be like extra pithy, you know, you might have a file called cob.web, cobweb, right? But okay, so you have this file and you're going to mix together the part that we're describing. We're like going to describe what the code does for humans, and then also that code itself. So it can go one way. You can take that document and you can weave it into something that is useful for printing and for viewing. So like something that you can read, and that path is through tech. And on the other hand, you could tangle it, and that would be like take out the code part and then just make a program that would run. Okay, so like his idea was, in this case, he said, you know, we'll use tech because he wrote that, and Pascal would be the programming language, and that's kind of like how it would work. So what does this look like in practice? So this is an example from his paper. And the idea, so kind of like the whole paper is itself an example of literate programming because he like walks through how you would solve a particular problem. And the idea is you're going to produce a list of the first 1,000 prime numbers. And he kind of like, basically you have these kind of placeholders where you say, okay, I'm going to define this part that's the program to print the first 1,000 prime numbers. And it's going to be this thing called program. We'll call it like print primes and then some output. And we have a constant. And then you have these other parts where you're like, and I'm going to tell you the details of that later when we get to it, when I feel like solving that one. So like it's sort of a skeleton of a little bit of code around, so like you can kind of just like focus on this bit, and you can write all sorts of stuff in here and explain what you're going to do and all of that. So then like in the next step, he goes through and says, so we shall proceed to fill out the rest of the program by making whatever decisions seem easiest at each step. What he's really saying here is like, you can do this in any order that you feel like, and you can jump around. The important part is that you just sort of have to say, okay, so here's the part where I'm going to print the first m prime numbers. And like, okay, so actually what we're going to do is fill the table P with the first m prime numbers, and then we'll print the table. So if we follow this print table P8 and jump ahead, and at this point, we're like, okay, so this part was like much later, and he's like, now that we've figured out like all of these variables and what we're going to do with them, you know, the process of outputting the table P almost writes itself. So, and then here's some actual code, but even this code still involves a little pointer to somewhere else. Okay, so that's what literate programming looked like initially. Like, and then all of this stuff happens inside of a LaTeX document, right? So at this point, and this is unavoidable, I just have to mention, like, a lot of this ends up feeling a little bit like developers commenting their code with very obvious things like, this is a cat. So there's a certain level of I think it's worth admitting that there's a certain level of the whole process that like sometimes it's easier just to write code and just like have the code be easy to read and kind of explicit about what it's doing. But there's other times where like you do need to explain what you're doing and have that kind of make sense. And I think also where I think why I think R Markdown connects so much with the R community is that one of these places where it's really important that you can weave these things together is when you're working with data and you have to get numbers and results into your outputs, right? So, but it is worth remembering, like, we don't have to like make everything a full-fledged literate program, right? So it's reasonable to have limits around this, right? So, okay, how did this end up happening in R? So here's a brief history of literate programming in R. So almost right away, our developers and like core R or whatever were like, this is a great idea. This is awesome. And picking up on the terms that Knuth used, they're like, let's do Sweeve. So in my telephone analogy, this is like the rotary phone of modern R Markdown, I guess, right? So here's kind of what it looks like. First of all, you use LaTeX, you're going to start in LaTeX. And there's a poll going around. Have you ever used LaTeX, however you decide to say it, LaTeX is fine. And okay, so, you know, it's a mixed bag, right? So this part seems really nice and clean. This is pretty easy. We're going to make a document. It's an article. There's some stuff we're going to use, and there's a title and an author. And then you start to actually have to write things down in LaTeX, and you get stuff like this. It's helpful that it's colored, but like if it isn't colored, you're also like, what do I look at? There's like lots of slashes and ats and stuff. But there's a little bit right here. We've got this this little chunk right here. And the idea is that that's R code that you can put into LaTeX. You can do more complicated things. So here, this is a demonstration of like putting together a figure. You're gonna run some code, plot the output, and then using LaTeX stuff, making figures and centering it and doing a bunch of stuff here with it. And the key here is like are these chunks. This idea that that you can kind of drop R code right into the document and render it. So here are two chunks. The first one is labeled fig1 plot, and it's not included, which means like the output doesn't end up in the rendered version. And then later there's another one that that's labeled fig1, and we're saying yes, this is a figure, and we're gonna not show this, right? So the syntax is like, if you've used R Markdown before, you're still like, I kind of recognize this. Like this sort of feels familiar, but also a little weird, right? You'll notice that so like here's what this actually kind of looks like. So this this chunk right here, you can see here's our Here's the output from this. You can see like the code itself is echoed into the document, but we don't see the output right here. And it's not until we later set up our figure and go through all of that that we see we have our figure that shows up. So there's also this cool kind of idea here that happens. Okay, so like, first of all, these are the, let me get the cursor out of the way. So these are the delimiters. This is how you say, here's where my R code chunk, or my, like, I actually don't even know if they call them R code chunks at this point, but here's like where the chunk of R code starts and ends. And so those are the two delimiters around the 2 bits of R code. And there's a neat idea here that comes from that literate programming paper, which is, okay, so I called this chunk up here, I called this chunk fig1 plot, and I'm gonna just use the same code from fig1 plot. I'm gonna just like drop that directly in here into these two, inside of the two, what are those things called? Angle brackets? Yeah, alligators. So that idea kind of like ends up making it into our Markdown, and it's pretty cool. So okay, so here's the figure that you see in the end. So the next step in our journey is we went from Sweeve happened. We're going to go to Knitter. Knitter is kind of like the Zach Morris cell phone of our Markdown. Please don't tell Yihue I said that. So he's the inventor of Knitter, and there's this cool interview from 2014 with at datascience.la. But anyway, with Yihue, where he talks about like why he made Knitter, and he's basically like, well, because I was trying to do my homework in Sweeve and it was annoying, and so he wrote Knitter. But Knitter was basically supposed to be an easier to use version of Sweeve, Sweeve. I think most people say Sweeve. Okay, so that was kind of the idea, but some really cool stuff happened with Knitter because it was a little bit more flexible. So about the same time that Yihue made Knitter, this idea of Markdown started to become really cool. So if you haven't used Markdown, this is a really awesome page to go to. R Markdown is basically, or Markdown in general, is just this idea that you could like mark up things in like regular to read characters. So like you can put this in a plain text document and see, and it kind of like looks like what it's supposed to be in the end, but then you can like pass it through a Markdown renderer and you end up with code with like text, here in this case that's bold, or you could use like this sort of styling to make a big header, that kind of thing. So this commonmark.org is a really, really good place to go if you're like, what is this magic and how do I learn how to use it? Go to commonmark.org. They have a really nice tutorial here too that will, this 10-minute tutorial will walk you through how to use Markdown. So some of the other stuff that you get with this, you get, so he kind of, because of the way that Markdown is set up, you get cleaner chunk and inline R code syntax. So Knitter initially did use that same like alligators, angle brackets to do the code chunks, and like it can actually work that way. But one of the things that it really did was make figures a whole lot easier to use and still work with, and it's still literate, so like it still keeps like all of those literate programming ideas of Sweeve. So this is kind of what it looks like. So let's say I have this Markdown that I'm going to write this in a like plain text document. I'm going to write this thing. So I'm going to write a little bit of prose and say, let's write another program that computes prime numbers called prime numbers. And so like you can see this section here, I'm going to kind of denote that this is code by putting it in the brackets, and that's kind of neat. And then I'm going to say, here's some code, and I have the 3 brackets before and after, and that is what marks it as that it's going to show up as a code chunk, as like a formatted, like it looks like code, right? But it isn't actually code yet. This is where Knitter steps in and can do some cool things to make it actually code. So like it just looks like this. It doesn't actually do anything, doesn't run, and it doesn't replace this with real code. It just prints it out and shows it to you. and formats it nicely. But Knitr then added the syntax where you can, so you take this sort of, so this part came from Markdown, this idea of 3 backticks makes it a code block, and it adds a little bit of extra syntax on top of that to say, okay, now this is our code, and I'm going to call this section of our code, or call it 2, and the stuff in here, I want you to actually run it. So when you render your document, you get like the actual text. You can see the code that comes out, the 2 + 2, like you see the original code, and then Knitr will add in the result and like print it into your document and show you what you had, right? So I think we're all pretty familiar with this, but then you can do pretty complicated things like making pretty cool figures, and you kind of like stuff a whole bunch of code in here, and but these sort of chunk options is where Knitr kind of made this literate programming cooler and more accessible and kind of nice, right? There's still like a ton of chunk options that you can go through, but UA has like really nice web pages that you can like look through what those are supposed to be, and like in this case, the syntax like doesn't really get in the way of understanding of like reading the source code like as much as it did when you were looking at LaTeX code. The other really cool thing about Knitr is that it added this idea of, I'm actually not sure if there might have been a way to do this in SWeave too, but it's a lot easier in Knitr to do this. So you can add inline elements, right? So in this last chunk over here, I have defined an X variable, I defined a Y variable, and then, and it's like based on, like an equation with some error terms, right? And so like I end up with these give me the points, and then I fit this to a linear model, right? And but the important part is like I can like access these things that I created, this like X and Y variable. I can go back and use them. I can use them in other places, in other parts of my document. I can reference them again later. And so, for example, if I wanted to show you like what is the 10th X and the 10th Y, and we're going to then predict, for X = 10, what Y, what's our predicted Y for that value, right? So so you can actually like drop those values into your writing, and so the really neat part is you have this sort of this is like the syntax to make code, formatted code in Markdown, and with just like 2 extra characters, just putting R space after the first backtick, then you can basically tell Knitr like, hey, okay, actually figure out what is in X bracket 10, and I want you to just like drop it in there, and so Knitr will do that for you. So our X is 10, our Y, and you can see like this Y is formatted like code. This is what code looks like on my slides. So that's this Y. And then this one isn't Y bracket 10 anymore, it's 18 dot whatever, which is the actual value that's inside of the 10th element of Y, right? And then like here's our predicted value. And it looks like if we just look at this one, our linear regression is awesome. Cool. So where Knitr like started to get like really, really cool is with when Pandoc came out. So Pandoc is a lot like the next generation of cell phones, like the Nokia, and you can like change the colors of your phone. Like how cool is that? And and this had Snake on it too, which was pretty awesome. And so Pandoc is this utility. This is like Pandoc's advertising around how cool they are. Is this graph? And the idea behind Pandoc is you like go from anything over here on the left side. Let me find my slides again. So like anything on the left side, Pandoc can turn it into anything on the right side. So most importantly, so like if Knitr can make your your code with R inside of it into LaTeX or into like a tech document, or if it can make it into Markdown document, then now Pandoc can do whatever you want with it. So anything on the right hand side is available for you to use. So Pandoc is it's a command line utility. So it's the kind of thing like you open up your terminal and then you go find wherever your report lives, and you have knitr on the one hand make your report into a Markdown document, and then you type pandoc report.md, and then you say -o, so that would be for output, and you say report.pdf, and after a little bit, Panda gives you a PDF file from your Markdown, which is really, really cool, because also you could say report.docx, and then the next thing you know, you have a Word document, and then you say .pptx, and you have a PowerPoint, or .epub, and you have an ebook, or .html, and like you're like, this is so cool. Like, how awesome is this? Except for one thing, there's a little bit of a tricky part. First of all, you got to go to the terminal and like find a terminal and figure out how to change directories and do all of that, and like that part can be kind of annoying. And then the other part is you have to remember all of the infinite options that Pandoc has. So I literally copied some of these. I copied all of these out of, so like the slides I'm showing you right now were written in R Markdown and rendered technically through Pandoc, and there's like a whole bunch of options. This is like the same part of what was in my options. The rest of it is just like line after line. Like it's like 3, 4, 5, 6 more lines of options. And like nobody remembers all of these. Some of them are like totally context dependent on what report you have coming in, or like what template you're using. There's a whole ton of complexity around this that ultimately like isn't so much fun. So that is where R Markdown comes in. So R Markdown stepped in and said, hey, cool, listen, just write your R Markdown document, and we'll let knitr do the part where you can send your R Markdown document to and turn it into a Markdown document. And then we'll pass it off to Pandoc, and we'll handle all of the options for you, and we'll just give you PDF, we'll give you HTML, we'll give you a Word document. And that's what R Markdown does. So R Markdown walked onto the scene, kind of like the 2003 iPhone. And this would be JJ Allaire and Yihue in one Steve Jobs in this reference. So it works like magic. There's no stylus. It's far more accurate. Multi-fingered gestures, patented. I don't think it's patented. It's open source. R Markdown is, not the iPhone. Okay, so let's reimagine R Markdown. It makes PDF reports, it makes Word documents, it makes PowerPoint presentations, interactive dashboards, books, websites, so much stuff. And one more thing, slides like these. So like R Markdown does a ton of stuff, but it's all built on this kind of tradition of literate programming, of sort of blending your code and the output together, and kind of like gluing together a bunch of different pieces. But like at the core of it, that idea still lives in R Markdown. So if you want to learn more about R Markdown, there's like the website is really nice. There's lots of options. There's a huge gallery that you can look through and see lots of different options of what you can do with R Markdown, and I highly recommend it. But I want to share with you today, in the last few minutes that we have, some of like the sort of crazier ideas that I've been messing with R Markdown, and I'm just going to show them off a little bit, right? So first of all, one of the really cool things that I've loved about R Markdown, and one of the reasons that I think it is so great, and I don't want to get into like, you know, the sort of tug of war over like which notebook technology is better, but one of the things I think R Markdown does really well and is really good at is that ultimately, if you keep in mind that you're going to go through that step of taking your your sort of the stuff that has special R properties, and you're going to pass through turning it into Markdown, and then you're going to transform it however you want. When you think of it that way, R Markdown will let you basically write the document as you're creating it. The document can write itself. So here I have two variables. I'm going to create a variable called years, 2019, 2020, and I have another variable which represents the grand total number of pieces of plastic that that we looked through, right? And one thing I can do is I can like write them. I can use paste. So this is like, let's pretend this is a regular R chunk. I'm going to paste them together, and I'm going to see what we get out, right? I think my slides got a little bit out of order. Let's look at this one, right? So I have my two variables. I'm going to put them in an R chunk, and then I have another R chunk here for plastics. And I'm going to create this items. I'm going to like paste together years and grand total into this sentence. In years, whatever years we collected, grand, and we're going to just like show the items at the end. So if I do this, we treat items that comes out as an R object. And so what knitr will do by default, or what R Markdown will do by default, is show you the printed version of that. So like it feels like you're on the console, the R console, and it'll show you like the first and the second item. And you can see like, okay, we have the text, and it's pretty nice, but I want the text to like actually show up in the document, right? So it's fairly straightforward. So you can do results equals as is. So the chunk option says whatever comes out of here, don't mark it up, pretend like it is the way it's supposed to be. And then we have to add this one little line to say cat, which is like R's way of saying print this like it is. And by doing these two together, we actually put this pasted together line, we put this line into the R Markdown. So this is like, this ends up in the sort of intermediate phase of, you know, returning rendering all of our R things into R Markdown. You have like, this is actually written out in Markdown. And then when you pass it off to Pandoc, all of that Markdown turns into something else. And at that point, what you see in the end is like actual pretty HTML text. So in 29, like the two sentences, and it looks pretty good. So this is awesome to a certain point, right? It gets really annoying when you're trying to do a lot of things. It gets annoying to like keep track of these, the quotes, what level of quotes you're at. If this sentence didn't involve any extra quotes, but if it did, it gets out of hand really fast. So I'm going to show you a package. There's a package called Glue. This is from the Tidyverse team. And Glue is, the idea behind Glue is, let's make this part easier to write. So let's take paste and make it a little bit more straightforward. So paste, by the way, will just put spaces between. So you can see like I have in here, and then my string ends, and then I add years. And you can see there's ends up being a space. So anywhere that we have like a piece that we're trying to paste together, paste will put an extra space in there. In this sentence, it works out fine. In other sentences, that also gets really annoying, like trying to control which ones have or don't have that extra space, right? So the Glue package kind of tries to solve some of this. So library, you install that package as Glue, and you get, then when you load the library, you can write something like this. So I'm still writing inside of a string, but this time around, like the string's pretty much coherent and it's all together. And if I want to reference a variable that comes from, I have to put it inside of braces like this. And you can like control some of these options, but this is the sort of default way of doing it. So this years becomes 2019 and 2020. It's also vectorized like so many other things in R. So I only have to say this once, but I get these two strings out. And, you know, okay, so now at this point I could do Glue, and then I could do the results equals as is and cat and all that stuff. But I want to do something even more fun. So this is where the idea for Epoxy came from. So it's Epoxy. It's like super glue, but more gluier. So the package lives on GitHub. You can install it using. Okay, so the chunk got hidden. You can install it using remote install GitHub, and then it looks a lot like this. So here's what I wanted to. This is what I wanted to show you. So the idea behind Epoxy is it gives you a glue chunk, which means treat this as if it were sort of glue, like glue, right? And inside of here, you can write whatever you want. It's going to end up being used as Markdown and coming out exactly as it looks. But you can do these braces and insert the things that insert values from your environment. So like in this case, I'm basically making a list here and having years go here and grand total go here. So there's like a lot of extra cool things that you can do with this. But where I feel like it really shines, and this is pretty much the reason why I built it, was because so like in this case, I'm making a list, and if I had a whole bunch more items, it makes it a whole lot easier to make that list. But when you're like templating and you do like summaries of data and you put it all together, it'd be really nice. Sometimes it's really nice to like have it all just sort of like having a way to like focus on the template and then inject the data here and there as you need. So so I worked up this example from the Tidy Tuesday data break free from plastics, and like here's the code. So to actual literate programming style, like this is the code that goes and downloads the data, and we're gonna do a whole bunch of dplyr stuff. And the idea is we're gonna like take this and we're gonna end up with a nice tibble that has country, year, the number of events, volunteers, and grand total. And this isn't quite enough. Let's actually summarize a little bit more. I want to get this down to just like each year. So I'm going to group by year again, summarize the number of countries, and just take the total number of events, volunteers, and grand total. And I'll help myself out a little bit by pre-formatting the numbers. But here's what you end up with. So I have a table that looks like this. And it would be really nice, or like, you might have like a ton of these, right? But for this example, we have two. So we have 2 years. We know the countries, the number of events, volunteers, grand total, etc. And so I can write inside of a glue chunk inside of my R Markdown document. The key here is to say the engine is glue, and then set data equal to this data frame. And notice I have countries, number of events, volunteers. And so then anywhere inside of this glue chunk, I can refer to columns from that variable or from that data frame. So year, volunteers, countries, number of events, grand total. And in the end, you get text that looks like this. So you also there's R Markdown in there, by the way. So you see here this, or just regular Markdown. But you have Markdown to make this bold, and I have Markdown to make this italic, and that ends up showing up in the output that we get. So that's kind of fun. There's a lot more that you can do with it, and if you want to learn more, you can hop over to the GitHub page. It's at Epoxy, and if you run into any problems, just let me know. I'll just be happy to find out that people are using this. So that's one idea. And the other idea, I'm just going to show really briefly, just a little snippet of this idea. But one of the really cool things. So in this example, what you kind of see is that R obviously has a very special place in R Markdown's heart, right? It's obviously very connected to R, and you're going to use R to kind of put everything together. But what I think is really amazing about R Markdown is that overall it's generally agnostic to the type of thing that you want to put inside of it. So you can have SQL chunks, you can have JavaScript chunks, you can have CSS chunks. There's all sorts of different types of chunks, and there's a really I don't want to say easy, but there's a mechanism available that you can, if you come up with something new that you wanted to create. So like in my case, I came up with this glue idea. You can make your own engine and make it work, right? So given all of that, I was like, wouldn't it be really neat if we could actually put like other things in these R Markdown chunks? And to show you this one, I have to switch my screen share over to here. And okay, so I'm in RStudio now, right? So I have this idea for this is called these are called shiny components. So the idea is that when you're writing shiny apps, like we haven't talked about shiny at all, but it's a way that you can make web applications with R basically, and you write R code, and then eventually it ends up becoming an app on the internet, and it's dynamic and it can use data, but like behind the scenes you're really just using R. So it feels nice and familiar. So so the idea here is, let's have, first of all, you can have global chunks, so like global shiny app things, and you put those in R chunks. So like this starting value being 12 is going to be available to the whole app anywhere. And then shiny has this nice separation of concerns where it says, okay, on the one hand, I want you to focus on just what you want to show in the user interface. And it says, so shiny would tell you like, okay, figure out like you want to put a button here, you want to have a plot output here, you want to have a, et cetera. And it kind of makes you do that. So that's like the UI side, it's called. And then there's also this server side. And on the server side, you're going to think through the logic that you would have to use to kind of like get to like wire everything up. So if you have a button that increments a number, then like, this isn't a really good example. A better example would be like, show me a row in a data table, right? And you have like a button that controls which row you're seeing. And like behind the scenes in the server side, you would do all the logic to figure out like how do you find that row in that data frame. And then you just send it back to the UI side, and the UI side's like, oh, cool, yeah, here, I'll show you the row. This is like a really high level view of shiny. But the idea that I had was, what if we use R Markdown and we put all of these things in separate chunks? So the idea here is I'm going to write my UI in a UI chunk. So I'm going to create an action button, and I just put this like tag list. There's like different chunk options that you can do, but this one just makes life easy for right now. And then I have server logic, and the server logic is going to find, here's my increment. So the input, this action button gives me, whenever you click it, like gives the server side a number that goes up. And so I'm going to call that increment. And so the value of that button is going to be stored in input increment. And then I'll just add it to whatever starting value we used. And then also just to like have something actually happen, like I'm going to show you on the console that like you see this number doing things. So the way that this works is you would library shiny component. No, not that. You want to library shiny components. And then you say you're going to make a new, so I'll call my component ink or whatever, but you're going to make a new shiny component. And you say, which means shiny component $new. And then I would say, let's look in here and we'll do this one. So I give it the path to my R Markdown document and run that. And now this component has a couple different pieces. So I have a server and a UI piece. So like if I look inside the UI piece, oh, I forgot. I need to do one little thing. I should also library shiny. That should have happened for me, but that's okay. So here's my UI element, and like here's like the HTML that Shiny is going to use for this UI element. And then and we can't see the server side, but what I can do is actually the Shiny component will give you a whole app that demonstrates what your component does. So here's it just has a button. That's all that you see in the UI. But behind the scenes, every time I click this, we have our starting value here is 12. And every time I click it, it takes our button number and adds it to the starting value. So the button number starts at 0. So 12, 13, 14, and it goes up. So this part is cool. And it's like, oh, that's neat. You can like put these things into R Markdown documents, but like why? So here's why. Because so basically what happens is like I take all the chunks that you put in here and rewrite them and wire it into a shiny, into like put it all into like all the right spots and to make and like shiny functions. And like one of the things that's really hard with shiny is like how do you make reusable like isolated components And there's a whole system for this called Shiny modules, and they get a little bit tricky to get your head around. The other thing that happens a lot of times with Shiny is like you have to, there's like all sorts of different pieces to these things. So you like usually you write your UI code in one file, you write your server code in another file. Maybe you have some JavaScript and you put that somewhere else, and then you have CSS and you put that somewhere else too, and like. And then there's some like dependencies and there's like all sorts of stuff, and like getting it like flipping between all of those things can be really annoying. It also like there's a feedback cycle of like you have to build a whole app just to see what your app is, what your like module is supposed to do, and then you want to be able to like drop your module into other stuff. So like all these things, I mean, they're not like that hard, but they definitely trip up a lot of people, myself included. So here's a more developed version of this, where rather than having just one UI, so this gets into like the syntax a little bit that you have to use, but the idea here is I'm going to have a UI called button, I'll have a UI called number, and then my like generic UI chunk is going to coordinate how those buttons, like how you put the button and number together. And then server side, we're going to do like a couple other things. And so if I replace if I go here and make my new component, Shiny component, new, and this one is in here probably. So now I don't have a UI function, I have a list. So I have a couple options. I have the button, which is defined here in this chunk. So I can look in button, and this button also has like arguments that it could take. I can choose the label and the icon and the class, which I kind of said, okay, this part here says I want these to be arguments into that. And then, or I have number, or I have UI. And then, but I can see what all of these things look like together if I do inc app. So this is like a default demo app using these different components. It's really useful if I am debugging or developing this and trying to get this together. But I can actually use these pieces inside of a Shiny app. So I'm just gonna, I like added a bunch of noise into this. Unfortunately, I'm gonna just run this and see what happens. So first of all, I created an increment. I created a component out of this R Markdown document. And then here are the parts that matter. I'm going to use each of those pieces, the button and like the number output that shows up in the UI. I'll use them separately. So here's a button, here's that button component. And importantly, I gave it an ID. I said ID 1. And then I have a button 2, and I gave that an ID of 2. And that's basically all you have to do to take the component that you've put together, the component from here, and turn it into a Shiny module. So at this point, each of these, this is the button for Shiny module with an ID of 1, and this is the button for Shiny module of ID 2. And then in my server, I do basically the same idea. I have a 1 and a 2 right here, and you can get the value that comes out of it with the reactive 1, 2. I'm starting to use a lot of the Shiny jargon, so excuse me, but like the idea is you can now like take these pieces and compose them. So this is like a Shiny app that I'm starting to use, and I've made a button out of my button component and for the 1 and for the 2, and so you can see that these will change the value. So button 1 changes the value for 1, and button 2 changes the value for button 2. And basically, I could write the whole component in one R Markdown document, including the dependencies that this required, all in one document, and then use it and reuse it in other places. And if I really wanted to, I could also in here, like start writing things like this is the default value for, whatever, and like document my component inside of the R Markdown document. So that's a really quick version of, or quick overview of Shiny components and 2 things I've been messing with R Markdown. Hopefully you leave this with a little bit more of an appreciation for the rich history of R Markdown and just how cool and flexible it is. And I have some resources here if you like want to follow up on any of these things. And as soon as I have some time, I'll make sure these slides are online and available, either through my webpage or through Rohan. So thank you, everyone.
Oh, thank you so much, Garrick. I'll just stop recording.